Hello students, welcome back and I hope everyone is doing well. We are going to continue the chapter magnetic effect of electric current. In the previous class we understood that if the current is flowing through a circular loop of wire, then it will get magnetized and it will produce the magnetic field and magnetic field lines, and the pattern we understood with the help of the diagram. So we are going to continue the same topic and then we'll move to the next topic today itself. So I hope you will be able to find interest in the class and you'll be able to understand the concept that I'm going to explain today. So overall, we understood that if we have a circular loop and the current is flowing through this loop, it will get magnetized and each point will have the magnetic field lines in the form of concentric circle, and at the center the magnetic field lines will be parallel, and overall the magnetic field is uniform and constant and maximum at the center of the loop, and that is given by the relation proportional to Ni upon R, where N is the number of turns, I is the current and R is the radius of the loop. So now one thing is, if just take an example, it is a circular loop just for example, and if you connect this with the battery, it will behave as a magnet, and once it will get magnetized, it will have a north and a south pole, because every magnet will have a north and a south. So in general, when the current start flowing through a circular loop, one phase become a north pole and one phase will become a south pole. So we can imagine that is within this circular loop, at the center we have a bar magnet such that one will behave as a north pole and other end will behave as a south pole. So which phase will be the north and which phase will be the south pole of the given magnet, that we can understand with the help of simple rule that we can easily understand. So to find out which will behave as a north and the south, we have a very simple rule called clock rule. So it's very simple to understand. Now very first, I'm writing something, I'm drawing something, try to understand what is this, and this will help you to understand the concept. So if you see, I've drawn two different symbols, and it is something looking like N and it is looking something like S. So N for north and S for south. Okay, so we need to relate. Now if you see this, the arrow mark which is shown here with the symbol is basically showing you a particular direction. So if you see, this symbol is showing you anti-clockwise direction. The way the arrow are marked here, you can see it is showing you anti-clockwise direction, and this one is showing you clockwise direction. So only with the help of these two symbols we can identify if the face of the circular loop is a north or a south pole. So the concept is, if we draw the N, that is north, you see it is basically showing you anti-clockwise direction, and this is showing you clockwise direction. So the concept is, if the electric current in the coil is anti-clockwise, then the phase you are facing is basically north pole. So all things are related. If we have the loop, one phase will be the north pole and one phase will be the south pole. So if you are facing this phase or back phase, that depends. Okay, so overall, if you are facing the one of the phase of the loop, such that if the current is anti-clockwise in the loop, then towards you is the north pole. So you are facing the north pole of the magnet. And if you are facing the coil or the loop such that the current is clockwise, then you are basically facing the south pole of the magnet. So simple rule is, with the help of this symbol we can understand N is something like N north, that is basically showing you anti-clockwise. S is something looking like clockwise, and that is showing you south. So if the current is in clockwise direction, you are facing south pole of the coil. In the anti-clockwise direction of the current we have, you are facing the north. So just imagine if the positive is connected here, negative is connected here. So once the positive is connected here, current will flow in clockwise direction. So this side will become what? According to the concept, if the current is clockwise, you are facing the south pole. So this pole will be the south pole and opposite will be the north. If you connect the positive here, negative here, current will flow anti-clockwise. And according to this, if the current is anti-clockwise, you are facing north. So this face will become north pole. So depending upon the direction of the current in the coil, we can identify if you are facing the north pole or the south pole of a given magnet, that is circular loop. So we can write down this with very simple concept, that is if you are facing the coil such that the current is clockwise, then you are facing south pole. Loop which is magnetized. Okay, and vice versa. So if you are facing the coils such that the current is clockwise, we understood for the current clockwise direction you draw the S. So you must be facing south pole, and if it is having a anti-clockwise direction of the current, then you are facing north pole. So only with the help of this symbol we can identify if you are facing the north or the south pole of a given magnet, that is circular loop which is behaving as a magnet. So I hope you understood this much. Now we are moving to the next topic, that is called solenoid. So this is related with the topic we have done just now, that is the circular loop behaves as a magnet when the current is flowing through it. And if we imagine to have this circular loop in the form of cylindrical structure that we see now. So this is just for demonstration to understand what is solenoid. So you can see I have taken this insulated wire, and that wire is given the term in the form of circular loop over a cylindrical base, you can see. So overall what we see, the different number of turns of the wire is given in the form of cylindrical structure such that its length is quite bigger than the diameter of this loop. So overall, if the wire is in the form of circular loop, that is showing you the cylindrical structure such that its overall length is greater than the diameter, then the structure is basically called solenoid, and this solenoid will also get magnetized when the current will flow through the wire. So overall we can say the circular loop in the form of cylinder which is connected with a battery will get magnetized, we know, and this will be called solenoid. And if it is having the length L and diameter D, your L is greater than diameter. So that is the condition for the solenoid. Okay, so I'm repeating again, any wire or insulated wire can be given many number of turns over a cylindrical base such that overall the loop is something like a cylinder such that its length is greater than the diameter. So Once it will be connected with the power supply, that is positive and negative terminal of a battery, one end, then this will behave as a magnet, this coil will behave as a magnet, and this is called solenoid. So I hope it understood. So we can say the circular loop in cylindrical form such that its length is greater than its diameter. That I have already written here, that is L is greater than D. It will behave as a magnet. So since this coil will behave as a magnet, it will have magnetic field, it will have magnetic field line pattern. Somewhere the strength will be maximum and minimum, that we are going to understand also. So I hope it understood. One more thing is, overall you should know before I start, this solenoid will behave as a magnet, and we understood in the circular loop, each loop will behave as a magnet where the current will flow through this solenoid. So each loop will have its magnetic field, and we understood if many turns of the wire are given, then what will happen, the strength will become maximum at the center, and one of the phase will behave as a north and one phase will behave as a south. So overall, if I connect this with the positive and this with the negative, just for example, so this is connected to the positive, you can see the current will grow clockwise. So if I have connected this phase with this terminal with the positive of the battery, you can see the current will go upward. Upward means it will move in a clockwise direction, and we know if the current is clockwise in a loop, then that phase will behave as a south pole. So if I connect this with positive, this phase will behave as a south pole, and opposite is negative, because that is positive, this will be negative, and you know negative means current is coming downward, so the current will move anti-clockwise. So if you see this phase, the current is anti-clockwise, and if you see this way, the current is clockwise. So the clockwise will behave as a south and this will behave as a north. So in general we can say, when we connect this coil with the battery, this positive will behave as a south pole and negative will behave as a north pole. So that is how the solenoid will have the north and the south pole. So I hope this is understood. Let me draw the fair diagram. So you understood what is solenoid. So any cylindrical structure we can take, and then over it we can give many turns of the wire, and once it is connected with the power supply, it will behave as a magnet with one side south pole and other side north pole, and overall it behaves as a bar magnet. So when solenoid is given the power supply, that is current, it starts behaving as a magnet, and that is very similar to a bar magnet with one side north pole and one side south pole. So we can say it behaves as a bar magnet when current flows through it. Okay, so I hope you understood this much. Any circular loop in the form of cylindrical structure will get magnetized when the current will flow through it, and one of the phase will behave as a south pole and other will behave as a north pole, and the magnetic field pattern or the magnetic field that is produced by this solenoid is somehow similar to the bar magnet. Okay, so I hope this much is clear to you. One more thing is to be taken care, whenever we are making the solenoid, the wire should be insulated. Means direct contact should not be there. If this loop and this second loop will not have the insulator in between, then they will come in direct contact, then it will not behave as a loop, because once they will get connected, overall we can say the thickness of the wire has been increased, so it will behave as a single loop. So if two loops will be connected together without insulator, it will behave as a single loop. So we must disconnect each loop from each other with the help of insulated wire. So that is to be taken care in the note, the wire should be insulated. Okay, so it is understood how many turns you can see? Many turns. Each loop will behave as a magnet, so each will have its own magnetic field. And if we don't have the insulated copper wire, then overall it will behave as a single conductor. So just imagine this wire is without insulator and they are having contact with each other. So it will not be counted as a number of turns, it will be counted as a single loop. So this is how the magnetic field will vary. So that is to be taken care. If you are making the solenoid, the wire must be insulated, otherwise the strength will not be good. So this much is clear to you. Now next thing is, since it will behave as a bar magnet, so it will have the magnetic field lines very similar to the bar magnet. So that is the next thing you should know. So in general, if we imagine this is the solenoid connected with the power supply, what will happen? It will produce the magnetic field lines. So magnetic field lines, if you remember, if this is behaving as a south pole and this is behaving as a north pole. So if we remember, the magnetic field lines pattern for the bar magnet is somehow like this, one side, and same with the other side. So this will be somehow the pattern of the magnetic field lines that is similar to the bar magnet, and we know the magnetic field lines move from north to south. So the direction of the magnetic field lines will be from north to south. So overall, the magnetic field lines pattern you can see, that is within the loop. We understood, if we have a current passing through a circular loop, it will behave as a magnet, and at the center of the loop the strength is maximum because the magnetic field lines will be parallel. So here also we have many circular loop, and overall the magnetic field lines within the loop or within the solenoid, we can say, will become parallel to each other, and here at the center only the strength will be maximum. So it is having a structure somehow like a bar magnet, but the all properties we are having with the solenoid are not similar with the bar magnet. So that is we are going to understand now. So I am making a fair diagram, that is overall, since it is behaving as a north and a bar magnet, it will have the north and the south pole, and the pattern will look like something this. So if I make a very fair diagram, it will have the one side, let it be positive and negative, so it will behave as a north and the south pole, south and the north pole. So at the center the magnetic field lines will be parallel to each other, okay, and outside it will be something in circular shape. So I am just showing you a few pictures now. So it can be finely shown like this, and it is starting from north to south. So that is final diagram that we can make for the solenoid. Okay, so I hope this is understood. This is the diagram for the magnetic field lines produced by a solenoid when the current will flow through it. At the center the magnetic field lines are very close, crowded and parallel, that we understood in the circular loop, and hence the strength will be maximum at the center or within the solenoid. So we can say within that space, the dotted space, the magnetic field B will be maximum and will be uniform as well. So within that particular space, everywhere the strength will be almost same, uniform, and it will be showing you the maximum strength. So if I take a point X here, if I take point Y here, if I take a point Q here, so it understood the magnetic field strength will be maximum at Q, that is within the solenoid, and at X and Y you should know the magnetic field will be almost negligible. So one thing you should know, outside the solenoid in general the magnetic field is almost negligible and maximum strength we have at the center. Why it is negligible, that will be discussed in 12th class, because there is having lots of other concepts. But for 10th class you should know, if this solenoid will behave as a magnet, at the center the field is maximum, outside the solenoid, that is x and y or different points, the strength is almost negligible. So we can write down overall the magnetic field is negligible outside the solenoid. So we can say here if it is B1 approximately 0, B2 approximately 0, and here this is B3 which is maximum. So the magnetic field is negligible outside the solenoid, and magnetic field is maximum and uniform within the solenoid. So uniformity understood. Why? Because magnetic field lines are parallel to each other. That is the first point we can write down. Second point also understood. So one more thing can be written here, that is magnetic field lines I'm talking about, are parallel within the solenoid. Okay, and one more point can be added here. One of the face of the solenoid or one end of the solenoid behave as a north pole, another behave as a south pole when the current will flow through this solenoid. So one end of the solenoid has north pole and other end has the south pole. So I hope you understood this much, that if the current will flow through this solenoid, it will behave as a bar magnet with one side north pole, one side south pole within the solenoid. Means if you see within the cylinder, that is within the space, the strength will be maximum and the magnetic field lines within this space will be parallel to each other. Outside the solenoid anywhere, the strength will be almost negligible, and that we can also verify with the help of magnetic compass. So this time I cannot show you practically that how the needle of the magnetic compass will reflect within the solenoid and outside the solenoid nearby the north and the south pole. But for today, just remember, if you place the magnetic compass outside the solenoid, it will not show you any deflection, but if you place the magnetic compass within the solenoid, it will show you maximum deflection. Nearby the end, the deflection will be there, and outside the solenoid there is no deflection. So we can say nearby the end of the solenoid, within the solenoid, the strength is there, but outside anywhere the strength is not there. Okay, so I hope this much is clear to you. And magnetic field lines pattern, you must practice. This diagram is very important, because when it comes in the paper, you must show the magnetic field lines parallel within the solenoid and one or two field lines outside. Just one or two, because outside the strength is almost negligible. So I hope this much is clear. Now since at the strength at the center is maximum, that is within the loop the strength is maximum, so we should know that is also given a particular relation. Means with the help of a relation we can find out at the center how the magnetic field will change. So we can write down at the center or within solenoid, the magnetic field is given as B is proportional to Ni. Okay, so that you should remember. Again, a formula that will help you to identify if the magnetic field lines will be maximum at the solenoid, then how will it change, means how we can increase the strength. So the relation is given to you, B is proportional to Ni, where B is understood, that is magnetic field within the solenoid, N is the number of turns per unit length. Okay, so that is just not number of turns but number of turns in a given length. I'll let you know properly the meaning. And I is the current. So the electric current. So you understood? More is the number of turns in a given length, more will be the strength of the magnetic field. We understood why. If the turns will increase, then each loop will behave as a magnet. So you can count 1, 2, 3, 4. There are many number of loops, and each loop will have its own magnetic field. So at the center, the strength will increase with the increase in number of loops, number of turns. Second thing is, overall, if you change the power supply, if you increase the voltage of the power supply, automatically the current will also increase in the loop. So same loop will have a stronger magnetic field if the current will increase. So by two different ways, by changing the number of turns in a given length of the solenoid, we can change the magnetic field at the center, or by changing the electric current. So more number of turns per unit length, more will be the strength at the center, less more is the current flowing through the solenoid, more will be the strength of the magnetic field at the center of the solenoid. So let's understand the meaning of small n. So if n is total number of turns in solenoid, so I'm talking about capital N, and L is length of solenoid. So let me draw it again. So overall we have a solenoid. We are having total length of L and total number of turns is capital N. So small n that is coming in the formula is basically capital N by capital L. So the meaning of this is, if we increase the length, and we don't change the number of turns, what will happen? The number of turns per unit length will decrease. So in a given length, only length will not decide the strength of the magnetic field. So for example, this is 2 meter, just for example. So we have taken 2 meter of cylindrical base, and over this I am giving 100 turns, just for example. So here 100 is what? Capital N. Length is what? 2 meter. So what is small n here? That is N upon L, that is 100 by 2, that is 50. So here small n is coming 50. Now take another way, another example. Now let's take, I'm drawing here, length let it be 2 meter, but 100 turns let it be 200. That is case 1 I have done, and case 2. So this is the calculation for case 1. For case 2, n will be how much? That is 200 by 2, that is 100. So let it be n1 and n2. So we understood in case 1, in the same length how many turns we have? 100. So small n is coming 50 only, and in the same length we have increased the turns. Now it is 200, so 200 by 2, it is coming 100. So it is understood in case 2 the small n is coming more, that is here your n2 is greater than n1. So it is understood within the solenoid the magnetic field will be greater or maximum in the case of 100, that is n2 will be 100 as compared to the n1, that is only 50. So we can say the way I have given the turns, if the turns are very close or the wires are very close to each other, then it is understood in a very less length we have maximum turns of the wire. But if you spread the wire, spread the loop, what will happen? The same number of turns will spread in a longer length. So once you start giving the gap, then what will happen? The magnetic field at the center will decrease. So it is not just the number of turns we have given that will decide the strength of the magnetic field, but if the turns are given, if they are very close or they are far away, that will also decide the magnetic field within the solenoid. So it is understood if the loops are very close, so the magnetic field will be maximum as compared to the turns which are far away. So if I say this is case 1, the magnetic field lines in this case, so let this length is 2 meter and magnetic field within the center is B1, and for the same length we have given less number of turns. Again this is 2 meter and magnetic field is B2. So let the current is also same. So let the current is 2 ampere, current is 2 ampere. So let this be case 1 and let this case be 2. So it is understood both coils have the same length 2 meter, both have the same current 2 ampere, but still the number of turns per unit length is not same. So here n1 will be greater than n2, so it is understood B1 will be greater than B2. Why? Because in the same length, here we have more turns, here we have less turns. So I hope you understood. That is, a solenoid is nothing but a cylindrical loop connected with a power supply that will behave as a magnet, something like a bar magnet with one side north pole and one side south pole. Outside the solenoid the strength is negligible, that is the strength of the magnetic field. Within the solenoid the strength is maximum, that is given as B is proportional to N I, and more is the current flowing through the loop, more will be the strength within the loop, more is the number of turns in a given length, like this case, more will be the strength of the magnetic field at the center. So I hope you understood this much. That is the meaning of a solenoid. So the last thing that I am going to discuss today is a electromagnet. So this topic will continue in the next class as well. So if we have a bar magnet, a solenoid that is connected with the power supply, and if within the coil, if you insert a magnetic material, so take an example, if this will be connected with the power supply, so it will produce the magnetic field, and within this cylinder if you place a magnetic material like iron, nickel, cobalt within it, then what will happen to this magnetic material? This will get magnetized. So within the solenoid, if you place a magnetic material, then it will get magnetized, and that is called electromagnet. So we can say the magnet is made with the help of the current, because the current is producing the magnetic field in the solenoid, and once the magnetic material is placed within the magnetic field of the solenoid, the magnetic material gets magnetized, and that is called electromagnet. magnet. So we can see the magnetic material so we can write down the magnetic material gets magnetized when it is placed within the solenoid. Okay, and this magnet so obtained is electromagnet. Okay, so I'm drawing again. So this is your magnetic material. So I hope you understood. We can magnetize a magnetic material with the help of the solenoid, and the magnet we get is basically called electromagnet. This electromagnet can be temporary, can be permanent. That we'll discuss in the next class. So for today is done. The topics we have covered, that is the clock rule to identify the north or the south pole of a coil or the circular coil when the current will flow through it. So it will get magnetized and it will have a north and a south pole. So we can identify with the help of very simple symbols, that is north and south. And then the meaning of solenoid. The meaning of solenoid, how it behaves as a magnet, and what will be the magnetic field lines pattern, the strength will be maximum or minimum, where and how to find out the maximum strength within the solenoid with the help of the formula B proportionate to Ni. And then at last the meaning of electromagnet. And I hope you remember in class 7 you made the electromagnet with the same concept, but that time the solenoid was not clear to you, but you understood now. If we imagine this is iron nail, and over iron nail we give many turns of the wire and then connect the wire with the power supply, then this iron nail will become a magnet. So what we are making a solenoid only. So overall same thing you did in class 7, that is you took the iron nail and over this what you did, you gave many turns of the wire and that was connected to the power supply. So it understood. You made the solenoid and within that solenoid you place the iron nail and that gets magnetized, and this is called your electromagnet. So if you remember this experiment you did in the previous class, so this is nothing but the electromagnet. Okay, so I hope the topic is clear to you today. Only one homework will be given to you and then you try yourself, because all things should not be done by me. That is the homework you have today. Find out the similarities and differences between bar magnet and the solenoid behaving as a magnet. So we understood that overall solenoid behave as a bar magnet, but still there will be some differences, there will be some similarities that you have to find out. So you try to find the maximum similarities and maximum differences between the two so that you can understand the solenoid and the bar magnet properly. So for today is done. Just take care, be at home. Thank you. Hari Om.